Okay, so today we're going to do this lesson just slightly different in that I'm going to make a video because sometimes when I use the calculator, I end up having to repeat a lot of stuff, and some people don't need the repetition and other people do. So this way you can go back and work through the problems at your leisure. So it says finding the zeros of a quadratic function by graphing. When do we use this method? Well, we use this method when we have a quadratic that we can't factor. So if the quadratic can't be factored, we're going to use our calculator and find the equation that way. So there are 4 steps to do this. There's actually 2 different ways you could go about this. I'm going to give you the first one way, and then I'm going to show you another way, and you can decide which one you want to use. So step 1 for method A, and that is you want to set your equation equal to 0. So in other words, whatever the equation is equal to, you want to get it so that it's equal to 0. Step 2 is to actually type the equation into the calculator. Step 3 is to use the calculator to find the zeros. So we're going to do second trace, and we're going to choose zeros, which means we're going to have a left bound, a right bound, and a guess for however many zeros there are. And in a quadratic, that could be 0, 1, or 2. And the final answer is we're going to write our zeros. Which is another way of saying solutions, roots, as ordered pairs. Okay, so I'm actually going to take you through method A for this first example here. It says x squared minus 4x plus 7 equals 9. So if I get that equal to 0, that means I'm going to subtract 9 from both sides. So I have x squared minus 4x minus 2 equals 0. Can't factor that because there aren't factors of 2 that add up to be 4. So I go to y equals. I'm going to turn off the box plot, so I just scroll up there and press enter so it's not darkened anymore. And I'm going to come down and clear whatever equations are in there. X squared minus 4x minus 2. And remember, when we graph, we always start on the standard window, so we do a zoom 6. And we're looking for where our zeros are. Remember, our zeros are x-intercepts, so I see 2 of them. I see 1 right here. That looks like it's between -1 and 0. And I see 1 right here. It looks like it's between 1, 2, 3, 4, and 5. So when I do this, I've typed the equation in, I've graphed it. Now I'm going to do second trace, and I'm going to choose number 2, which is the 0. So the left bound, I want to find my small one first. So I'm going to scooch over so that that floater, that flower, that butterfly, is on the left side. Now if you don't want to scooch, I had mentioned that it looked like it was between -1 and 0. I could type -1, and that pops up with a line there. I suggested that the right bound was 0. Type that in, there's a line there. The intercept occurs between those 2 blue lines. So I press enter, and my first answer is -0.45 and 0. So I got x equals -0.45. So one answer is -0.45 and 0. Now I need to find this one. Now again, I can see from the graph where it's between, but if I look at the table, Okay, I'm going to go back and change my table. I want to start at 0 and count by ones. So when I look at this, I can see at 0 it's negative, at 1 it's negative, at 2 it's negative, at 3 it's negative, at 4 it's negative, but at 5 it's positive. So somewhere between 4 and 5, it has to be 0. So I'm going to go to second trace, and I'm going to choose number 2, which is a 0. And it graphs. And we said it was going to be between 4, so press enter for 4, and 5. And I press enter for 5. My guess is somewhere in the middle. Looks like it's 4.45. So my other solution is when x equals 4.45. And so that's positive 4.45 and 0. And again, when you do this, if you get something it doesn't say 0 here, maybe it says 2.6 e negative 17, that's the same as 0. Okay? So, method B for this would be, instead of setting it equal to 0, we're going to go to y equals, and we're put in the left side of our equation in y1, and the right side in y2. Okay, so that's our first step then. We're going straight to the calculator. The second thing we're going to do is we're going to graph it. And you want to start with a zoom 6. And when you graph it on a zoom 6, you should be able to see the point of intersection. So we're looking for the point of intersection. So what we're doing then is we're going to go to second trace, but this time we're going to find the intersect. And when we find the intersect, it's going to ask us for the first curve, and we press enter. It's going to ask us for the second curve, and we press enter. And then our guess, and we press enter. And that's going to give us what x equals. That's our 0. Okay? So, trying this the second way, so what I'm going to do first is I'm going to go to y equals, turn off my plots, I clear what's in there, and this time I've got 4x squared plus 8x minus 2. That's one graph, and the second graph is negative 5. So when I graph those, I should see two graphs. I just pressed graph because my last window was zoom 6. And I'm looking for where this intersects with negative 5. I do see two intersections. I see one here and one here, so I'm going to have to calculate both. So when I do second trace, I want to calculate the intersect, which is number 5. So my first curve, my second curve. Now, see how the flasher is? It's closest to the one on the right. If I leave it on the right, that's going to give me the one on the right. If I scooch it to the left, it's going to calculate the one on the left. And that tells me that x is negative 1.5. Then I plug in to find the second one, second trace, number 5. First curve, second curve, and again I want to scooch over to find that intercept. And this time I've got x equals negative 0.5 for my 0. So my solutions are negative 1.50 and negative 0.50. And again, you could choose either method, but it's up to you whichever one you think is easiest. And it's really a matter of choice. Okay? Now, the same thing holds true if you look at the next page says finding the zeros of a polynomial by graphing. When do we use this method? Anytime we have a polynomial degree greater than 3 or equal to 3 that we can't factor. And the steps that we wrote here are the same steps that we had on the other page. So if we do method 1, if we do method A, we set it equal to 0. We type it into y equals. We graph it and find the zeros. And we write our answers as ordered pairs. That's if you want to choose the first method. If you want to choose the second method, which you can also do, okay, if you want to choose the second method, okay, same thing, except we're going to type each side into our calculator. Our left side is y1, our right side is y2. Then we're going to graph, and we start with the zoom 6, hoping that we can see the intersection. You've got to be able to see where they intersect. If they don't, if it doesn't show up in your window, then you're going to have to change the window. This time we're going to do second trace, and we're going to find our intersect. And then you write the answer as ordered pairs. Okay? And again, it's your choice what method you want to use. Okay, so I'll do this first one using method A. So if I'm going to do method A, I'm going to get it equal to 0. So 8x cubed plus 3x squared plus 10 equals 0. And I'm going to go to y equals, clear out the two equations that I have, and again make sure my plots are off. 8x to the third, bring it down, plus 3x squared plus 10. Zoom 6, because I said I want to do the standard window, and I'm looking for where it crosses the x-axis. Once. Just once, it looks like. Interesting, but okay. So I want to find where it intersects. So I go to 2, I'm looking for the 0. Looks like it's between -2 and -1, but I'm going to check that on my calculator. At -1 it's positive, at -2 it's negative, so indeed that's where it crosses. So between -2 and -1, so second calc the 0, between -2 and -1, and my guess is -1.22. That's what x is. So our ordered pair is -122 and 0. Well, it makes me wonder why that light came on. Okay, now the second equation, if I graph this and I do method 2, so I go to y equals, I clear out what's there. Well, actually, let's go back and let's do the same equation that we just did. So we had 8x to the third plus 3x squared plus 12, and then we had 2. And we want to find where they intersect. So zoom 6. There's the x cubed function. And then we'll graph y equals 2. Here's our intersection. So we do second trace, number 5, first curve, second curve, and guess. And I got negative 1.22. There you go. Same thing happens over here. If we go to y equals, clear the two equations that are there. We've got negative 4x to the third minus 5x plus 100. And then we've got negative 12. Notice the difference between a negative and a minus sign. If you put in a negative, that's not going to give you the same thing. If I put in a minus sign there, at the beginning it's going to say error. Okay, my window, it's gone all the way up to 100 and all the way down to 12. So if I do a zoom 6, I'm not going to see my intersection. How do I know that? Well, because my standard window goes from negative 10 to 10. So when I do my window, I know my y-intercept is at 100, and I know my negative one is going to go down to negative 12. So what I might do is maybe go negative 20 to 120, and I might count by 20s. Oops, that's on my x. I'm going to keep my x's the same. But I might go negative 20 on y to 120 and count by 20s to avoid that fat axis. So that now when I graph it, there's my graph coming in, and then there's negative 12. And again, I want that intersection. I want that intersection. So when I do that, second trace, 5, first curve. Notice the first curve is the blue curve, and the ordered pairs are named in blue. Then it goes second curve, and the equation up here is in red, and so the equation here is in red. So even if you can't see the ordered pairs that it's using, they're there in red. And you can guess, and we've got x equals 2.90. So we have the ordered pair 2.90 and 0. And again, if you did it the other way, where you subtracted 12, or you would add 12, we would have 112. And if we calculated the 0, left bound, we think it's between 2 and 3. 2, right bound 3, somewhere there, same exact one. So it's your choice. Okay? So what I'd like for you to do is take some time, do these 10 practice problems, and the closure. The closure you're going to turn in.